All right, this is the last example that we skipped over on continuity. It was in section 1.6. And we just wanted to look at one more piecewise function that had, it wasn't continuous on the entire graph once you put it together. We did number 5 in class, and we figured out that when we plotted these two different tables, they shared a common point that was filled in because of the equal to, and therefore the graph ended up being continuous. So for this one, we're going to graph these two as individual tables, and then on one picture, we'll see what this looks like to see if it's continuous or not. So our first table is 5 minus x, remember that's our function, if we're between -1 and 2, and they're both closed. So we're going to be using -1, 0, 1, and 2, but the endpoints are going to be closed circles. And then our second table is from 2 to 3, but the beginning is open, but the ending is closed. So when we plug these in, 5 minus -1 is actually 5 plus 1, so that would be 6. 5 minus 0 would just be 5. 5 minus 1 would be 4, and 5 minus 2 would be 3. For this one, 2 squared is 4, minus 1 is 3. Oh, I think I had an error on this one, sorry. This was supposed to be just less than. Otherwise, this is also going to be continuous. So let's fix that real quick. So on your paper, you'll want to change that one to a less than. So this is also open because we want this to be open on both sides. And then when we plug in 3, 3 squared is 9, minus 1 is 8. Okay. So now that we fixed that, I wanted to show you an example where we don't say that it's continuous on the entire piecewise function. So let's plot -1 and then up 1, 2, 3, 4, 5, 6. That's a closed circle. 0, 5 is just a point, 1, 4 is another point, and 2, 3 is an open circle. So that's kind of just part of a line. The other graph, we only have 2 points. We could get a decimal in between if we wanted to, but I think this will be sufficient. We know this is a parabola shape. It's also 2, 3, but it's still open, so nothing's going to change there. If this had been closed, we would then have filled that in. And then 3, 8. So this was up at 6, so 7, 8. And that's closed, and we know this is a parabola-like shape. So because, even though they connect at the same point, because it's open, we know that this is not continuous on its entire domain. This is continuous on -1 to 2 union with 2 to 3, because we never go smaller than -1 and we never go bigger than 3, but we do not have a continuation at 2. We have that open hole there. And that's all I wanted to show you, just another example of what a piecewise function could do. It doesn't always have to be continuous. All right, that's the end of the video.